We're looking at the first lesson of Chapter 5. Now, please remember, everyone, if you're paying attention, I don't have to get this question again, and we will know the answer to it automatically. This is the beginning of Chapter 5. Your test is not on Chapter 5. On Friday, that test is up just covering Chapter 4. So this is just new material so that I can use the time efficiently because of the way things got laid out from all the breaks and stuff. So don't worry about this on the test, but you will have a test on this material at some later determined time. Graphing relations and functions. We're talking about the first lesson here, 5.1 or 5-1, the coordinate plane. I like this lesson. It's going to be a nice break from some of the harder stuff that we've been looking at. The coordinate plane. This is a lot of review. In fact, we went through most of it last year, so it shouldn't be too difficult, I hope. We are going to add a little bit more. I wanted a little bit more preciseness to what we're doing, so we're going to have a little bit more of that, and then I'm going to focus on the form of what we do here, so we need to make sure we're clear with that. Yes?
Do we take our notes on the graph table?
Oh, you know what? I apologize, guys. Take this in your notebook. I'm so sorry. I forgot you have a notebook, so I apologize. This could be for your homework. So again, I'm sorry.
You're welcome.
And you can staple it into your notebook. That's cool. Or put it in your notebook. So that's all right as well. I apologize. Yeah, I'm having a rough Tuesday morning. No, I was telling another student in the class. So I take classes online, and I start taking it once I put our boys down. So at 8 o'clock, that's when I start working. And I had to do a lot of reading, and I foolishly printed out little font. So I'm reading this packet, it's like 10 pages of this little font. And it's interesting reading. I really enjoy it. But I'm lying on my couch reading, and my wife's doing the dishes, and she, we're separated by a wall, because if she would have seen me, she would have helped me out a lot. But I'm reading there, and I'm like, okay, that's good. I'm like on the 3rd page out of 10, and I do this. I put my paper down on my chest, and I just close my eyes. I'm just going to take a little break. And the next thing I know, my wife's shaking me, Bobby, it's 11:40. I'm like, oh, man. So I had to go to sleep now. So I had to go. I was done. I was done at that point. But I was tired. So what I told the students, that was unwise. I struggle reading at night. So what I should do, instead of lying down and trying to read it like this, I should sit on a chair up and read like that. It's a lot harder to read. Fall asleep when you're sitting up as opposed to lying down. Yes, sir.
What's this?
I'm not sure. Oh, it's a book of graph paper. So you have a stash of graph paper. That's kind of cool.
I have another stash too.
Ooh. Okay.
Was I supposed to give it to you?
I think so, but you don't have to right now. That's all right. Thank you, Wyatt. Okay, let's talk about a few things here. I want you on that paper to graph a coordinate plane, and it doesn't have to be perfect, but try to make it neat. And don't make it too small to where it's very hard to see what you're trying to write in there. I would say it takes about a quarter of your paper, like a quarter, the top left quarter or quadrant of your paper, to be a good size. Of either paper, this paper, whatever paper you're using, it should take a quarter of it, this little graph right here.
So this is not finished, right?
Mm-hmm. Yeah, and again, I messed you guys up, so I'll try not to do that with the other class. Try not to. Can't promise that.
Don't fall asleep.
Yeah, if I don't fall asleep. All right. We're going to label some things here, and these should be review. So I hope none of you are like, whoa, I didn't know that. Really? Well, if that's the case, at least you'll have another chance for it. Okay, these lines here are perpendicular lines. Do you guys remember what perpendicular means, Josh?
All the intersections are like a 90-degree angle.
Yeah, these two lines intersect and they form a 90-degree angle. So that's correct. So try to make your coordinate plane as perpendicular as you can. So if it's skewed, it'll mess you up on your graphing. Trust me on that. Okay, this line right here that is vertical is called the blank axis. Fill in the blank. Everyone? Y-axis. So I'm going to label that Y-axis. That's the vertical axis. Vertical means up and down. And then the other axis, the one that is considered horizontal, or you can think left to right, would be called the blank axis. X-axis. Okay. The reason I even go through that is because the X and Y, that means something when you're graphing, okay? That'll mean something this chapter. It'll mean something in the next few chapters that deal with graphing. So you got to know that. Okay. This spot where these two axes, that's the plural of axis, axes meet, is called the, what's this point where they meet? The origin. So you need to know that, origin. All right, so those are the parts so far. And then one last little thing that we need to be familiar with, and this really helped me out, understanding this next part, really helped me out with pre-calc, because you're going to deal with lines, and it's kind of cool. You're going to deal with a line, or you're going to try to deal with a line that has like one of the sides of a triangle. Sorry, I should clear this up. You're going to deal with a triangle where one of the sides is 0 in length. Like 0 in length? How do you so I sketch it out. I draw this triangle. It's a right triangle with one of the legs being 0. And just sketching it out will help you to understand what you're talking about. But the quadrant is going to be big time in those courses, okay, as you get further along. So does anyone know what the names of these quadrants are? When first of all you're thinking, what's a quadrant? So what's a quadrant? Quadrant. 4, right? So what's the first quadrant? How would you describe it? Yes, sir? Top right. So we're going to label that quadrant 1. That's Roman numeral 1. So quadrant 1. Okay, what's quadrant 2 though? And this is where you can throw yourself off. What's quadrant 2 here? Eli?
Left.
Good. The top left. There you go. Top left. Quadrant 2. Quadrant 3, which hopefully you're starting to see something. Yes, sir? Why?
Down.
Yeah, you go down. It's the bottom left. Quadrant 3. By the way, when you label the quadrants, Roman numerals, please. So 1, 2, 3 are easy enough. But then 4, which is the last one, how would you write that with Roman numerals?
1 and then a V.
Yeah, IV. IV is 4. Roman numeral 4. Okay? All right, so those are the quadrants. Now, what's nice about the quadrants for us, even if I'm not even thinking that far down into math, is that there are certain characteristics of the ordered pairs that fit into each one of these quadrants, and some of you might pick it up, some of you might not. If you do, it's going to be very helpful. Do you have a pattern or something?
Yeah.
Yeah, what do you notice about that?
1 is positive.
Oh.
And 2 is positive negative.
Close.
Negative positive.
Negative positive.
And the other one is positive
Negative negative.
negative. Wait.
Negative negative.
And then the other one positive.
And that's always the case. So if you have if you have an ordered pair where the coordinates are both positive, it has to be over here. Has to be over here. If you have two numbers in an ordered pair that are both negative, has to go down there. Like there's no doubt about it in my mind. And then whether the first one's positive or the second one's positive, they might go in 2 and 4. Okay, so that is a pattern. And that is helpful later on as well. Okay, here's something you need to know. That's all the parts of that coordinate plane. We'll get to that in a little bit. Speaking of ordered pairs, what is an ordered pair? It comes in this form, and then I'll give Benton a chance to give me what is an ordered pair. So an ordered pair is in the form x, comma, y in parentheses. What is, like, okay? Yeah?
Is ordered pair a pair of numbers that are related due to the graph or something?
Yeah, they're going to be related to the graph, the coordinate plane, and they are related, and they're in a certain order. So if we write x, y, that's the order we're going to use. Don't use yx, and then you can take all these concepts and take them literally. Mr. A said the first one's x, the second is y, so stick with that. You don't have to change it. So just to help you out, the first number is x. That is the x coordinate. So if you see x coordinate, you're like, okay, I know what that means. It's the number that corresponds to the x-axis. The second number is the y coordinate. Bless you. The y coordinate. Ooh. And that number corresponds to the y-axis. Bless you. Okay. So when I'm dealing with an ordered pair, I'm always dealing in this way. I'm looking at the horizontal axis first, then I'm looking at the vertical. Horizontal, then vertical. In that order always. Okay, let's look at example number 1 and see how we actually use these on our problems. So example 1, and I think we have several problems here. I'm going to do something I haven't done before, and it's good for your notes. So like if you're totally confused on your own, you're like, Mr. I don't remember what's what. Hopefully the notes will help you out. But who can read for me example number 1, the instructions? Okay, go ahead, Ben.
Write order pairs for points B, F, G, and H shown at the right. Name the quadrant in which each point is located.
Okay, so they gave you the coordinate plane. They gave you the points where they belong, and they list out the letters according to their points there. Okay, E. What you have to do is this. So I'm going to draw a little sketch of that. For E, I'm just trying to sketch here. E is like down here somewhere. This is not to scale. Okay, what you have to do to find the ordered pair of E is starting at the origin, where do you go, left or right? So how many do you go, and which way do you go? Do you go to the left, or do you go to the right? I know Benton knows. Margot, you go to the right. How many times do you go to the right? 1, 2, 3, 4. Okay, so you end up going 4. And I'm going to write this 4 right. Okay, I went 4 right. And then from there, where did I go? From right at this spot, where do I go? Now I'm thinking up or down. So go ahead.
-2 down, or 2 down.
Okay, you go 2 down. So I'm going to write here 2 down. You went 2 down. Okay, since you know that, you already have the ordered pair for E. Okay, this is how you write the ordered pair. You write the letter E, because that's the one we're talking about. You start up your parentheses. 4 right is described as a positive number. 4 right means positive 4. What is 2 down? How's that represented? -2. So if you're like, I don't know, how do you know if it's positive or negative? If you went to the right, it's positive. Therefore, if you went to the left, it would be negative. If you went down, it's negative. If you went up, it's
Positive.
okay. So there's a pattern there. This would be my answer for E. Okay, I found E. And then F. F. I'll sketch another one here. And you don't have to draw these sketches. You have it in your book, but I just want to picture it. So this is F. So it's like down here. Okay, so that's F. Okay, from the origin, starting right at the middle of the 2 axes, where did I go left or right?
You went
0. I didn't go left or right. So I'll put here 0, left or right. Because I did not go either way. 0 left to right. And then from there, where did I go? So I'm still at the origin. I went 5 down. Good. So I'm going to write here 5 down. Okay? So what would be my ordered pair here? Well, what does 0 left or right stand for?
0.
It says 0. You didn't go either way. And then 5 down would be? -5. So that's my ordered pair. So which direction are we looking at for the first number? Which directions are we looking at?
You're looking in the direction of left to right.
Which is which axis?
The X.
Okay, and the second number we're looking
Is the
y-axis, which is going to be up or down. It's always going to be that. Okay, please don't mix that up. I'm trying to write this down for you. If you're like, Mr. I mix these up a lot. No, I'm trying to help you. Okay, this next one is tough. I'm going to sketch it a little bit more in detail. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so 1, 2, 3. So right here, and this is G. G, I'm looking at it, and I'm thinking, which quadrant is it in? Third quadrant. What do I remember about the third quadrant? I know that both coordinates have to be negative. So if my answer doesn't have both coordinates negative, I'm wrong. There's something wrong because it's not describing what we just said. Okay, from the origin, where do I go, left or right? I go left. I go 1, 2, 3, and a half. Now you're like, Mr. A, are you sure it's a half, or is it more like a third or 2/5? Which one is it? We're not going to try to trick you. Just try to look at it. It's about a half. So we went 3 1/2 to the left. We went 3 1/2 to the left, right? Okay, from there, where did we go? Walker?
We went down 4.
Okay, we went 4 down or down 4? No. There you go. All right, so how would you describe this order pair? Yes, sir? Or do you have a question?
I do have a question. Like, so are you sure it's not because it looks like it's one verse?
3.4. Okay.
3.6.
My guess is that. If you get, I'm not going to give you ones that are odd. Halves are good. Even quarters might be good, but that one's, I can see what you're saying. Get your rulers out and start measuring. Yes.
This is kind of a stupid question, but
No, ask.
the one that is on the y axis.
Axis.
Which that like the 0, 5.
The F one.
Which quadrant is that in?
Ooh, what a good question. We haven't gotten to that yet because we're going to do them all, but which quadrant is it? Might as well answer now. F. Point F is in which quadrant? How many of you say 3? How many of you say 4? 3 1/2.
4, because the 0 is a positive number. It's none.
It's on the y-axis.
Okay. Oh, wow. I heard all the answers. I think all the possible answers, which is good. You guys are thinking. And there's one answer. The answer is y-axis. It's on the y-axis. Yeah. All right. I'm not going to measure it, but if it's on the y-axis, if it's supposed to be on the y-axis, it's this y-axis. That's a good question. Glad we figured it out. A little bit off?
Yeah.
I'm going to write to the publisher, and I'll let them know. Oh, they'll hear it. All right, last one here for this part. Did I put -4? Oh, thank you. Sorry.
Oh, Miss Ray, that was also correct.
All right, yes. No, good. It's negative 3.5, and then it went down, so it's -4 as well. So it's negative 3.5, -4. That's your answer to that one. All right, last one on this section. You have H, which is up here. Somewhere up here. This is H. Okay, from the origin, you went which way? Left, and then you went up. So how many did you go to the left? 6. So that's -6. How much did you go up? 3. So it's +3, and then the letter. Wow. You know what? Honestly, what I think it's doing is it reacts to this. Like if this is together, it does something to it. So I need to back it up a bit. Maybe not. It just outsmarted me. It should be H and then -6, 3.
Yeah, report it to the authorities.
To the authorities, yes. Okay, Margot, you had a great question because this problem said not only to give the coordinates, but to give the quadrants. So without looking, Kyra, which quadrant is point E in?
It is in the
4th quadrant. So that would be part of my answer. 4th quadrant. Wow. Okay, I'll put it over here. 4th quadrant. So that would be the quadrant there. All right. And then next, F. We talked about this one. Which quadrant? So if it says name the quadrant, you're going to say y-axis. You're going to write y-axis. Okay, it's in neither the 3rd nor the 4th. It's on the y-axis. And then, which quadrant is this one in, Lisby? 3rd quadrant. And then the last one, H, is in which quadrant, Owen? 2nd. And don't forget Roman numerals, okay? So I hope you guys can do those. Pretty good so far? Pretty easy, right? We're almost done here. Just one last little thing, and it's still review. This is an important note. When it says to graph, when it says to graph a point or graph an ordered pair, or to graph an ordered pair means, all it means is this. It means to draw a point on the coordinate plane. So it's not a special thing. It just means draw that point. To graph an ordered pair means to draw a point on the coordinate plane. Excuse me. And that for now doesn't mean much because, like, okay, I get it, draw a point. But when I say to graph a set of ordered pairs, that means you're going to have to do multiple dots. And then if I say to graph a line, you're going to have to draw a line on the coordinate plane. So this will change as we keep going through this chapter. Okay? All right, example 2. Let's finish this up. Okay. Bless you. Example 2. Plot the following points on a coordinate plane. They could have also said graph the following points on a coordinate plane. So what I want you guys to do is on your paper, on your notebook paper, whatever that is just draw yourself another coordinate plane. And the highest you're going to go is 8 in any direction. So don't go further than 8. But I want to see a good, neat graph. I think you have the answers right there. So it's not like I don't know what to do. I want a neat graph. And if you're doing it on notebook paper, you just have to be a little bit extra careful, which just means go just a tad bit slower. So here, if I want to draw my spaces, I want to get them as evenly as possible. And I'm not going to go all the way out to the 8 because I'm just going to show you here what I mean by even. And it doesn't have to be perfect. None of my spaces are exactly the same, but I'm trying to make them as close as I can. And that took me maybe 5 to 6 seconds to do it. Okay, so just draw your spaces. And then what you're going to do is you're going to plot the following points, N, K, and L, on that coordinate plane. And you have to put the dot with the letter next to it in order for us to know what you're talking about. I'm also going to do, actually, you know what? Let's just use this for illustration's sake. Okay, I have this graph on my paper, and I'm going to graph the numbers on my coordinate plane as well. So you do it, and I'll do it, and then I'll show you what's going to happen when you get stuck, because there is going to be one I get stuck on. So -3, -5, 1, 2, 3, 1, 2, 3, 4, 5. So that's N. All right, N's good. K. 1, 2, 3, 4, 0.5, and then what's the second number? Positive or -8 for K? 1, 2, 3, 4. Oh no! I don't have 5, 6, 7, or even 8. If you have this on your paper and you're like, what do I do? Just pretend there are more tick marks. So if I went 4.5, 1, 2, 3, 4, 5, 6, 7, and I'll just put it right here. Okay? You just extend it. You could draw the line up, but you don't have to, and then you just write K. That's fine to do. That's okay. Sometimes you don't have the whole graph.
What if it looks like
okay.
it's on 7 instead of 8?
Like mine does?
Yeah.
You don't like mine?
You want to fight? Yeah, I don't like yours.
Okay. That's okay. Don't worry, I forgive you. Okay. 6, 0. 1, 2, 3, 4, 5, 6, and then 0. I didn't go up or down, and this is L. Okay. Do you guys get that? You're going to see this concept again where you're like, Mr. A, you didn't draw the lines all the way up there. That's okay. You just pretend. There you go. Yeah, it's pretending. It's fascinating.
It's a game.
It's a game where everyone's a winner. No, maybe not. Okay, but anyway, look on page 256. I'm going to end out with this note here. I just want to mention this. This is kind of it's a deep concept, but it's an important concept. 256, and then I'll give your homework. You see that box, the yellow box there? It says Completeness Property for points in a plane. Okay, And this actually goes with what you guys are already telling me, so please listen up. Remember on their dots how we said, no, Mr. A, that's a little bit closer to like 0.4 or 0.3, whatever you thought it was. You're actually getting into this completeness property. What the completeness property is saying that is this. When I put a dot here on 6, 0, this dot represents exactly 1 point on the graph. And that, in this case, would have been 6, 0. Okay, it represents that point. And every point on this coordinate plane, infinitely going out there, can be represented with one dot. Okay? Now, the reason I even bring that up is watch this. Ready? Okay, what point does point, we'll just call that Q. What does point Q represent? 2. 2, all right, so 2, 0. But if I look at it real carefully, I'm looking at it thinking, isn't this really like 1.90? Isn't it kind of close to this point right here, or 1.870? Okay, this 1 point represents 1 point on this line. It doesn't represent a conglomeration of other points, because this actual point is taking up more than one number. But we're going to say it represents only 1 point, because we cannot just draw 1 point. Any length or width of a point will cover more numbers than you wanted technically. So that's called the completeness property. So be careful with that. Yeah, like if I really wanted, let's say -2, 0, I'd put, there you go. There's a little mark right there. But even that little mark is too wide or too tall or whatever. So don't worry too much about that one. Okay, your homework. 13 to 37 odd. No. You want more?
How do we do 37?
Read the instructions.
Oh, why?
No, just read. I'm just saying, read them.
No, like,
Oh.
Walker. No, yeah, I'm not trying to mean that in any. But look, at 37 says, grab each point, then connect the points in alphabetical order. Yeah, it's a lot, but it's really not that tough. You'll see a design when you do that. It's a cool design. It depends on which school you like for college football. Yes. No, you're not going to see Clemson Tiger. No. It's not Clemson. Sorry, guys.